Hello, everyone, and welcome to today's webinar, Alinity M-STI, the Extragenital Samples, from Assay Design to Real-World Experience. I am Michelle Ashton of LabRoots, and I'll be your moderator for today's event. Today's educational web seminar is presented by LabRoots and brought to you by Scientific Affairs Molecular Diagnostics at Abbott. We encourage you to participate today by submitting any questions you may have during the presentation. To do so, simply type them into the Ask a Question box and click Send. All of your questions will be answered via email following the webinar today. You may also submit any technical issues here as well if you have trouble seeing or hearing the presentation. I'd like to now welcome our speakers. Our first speaker, Dr. Kevin Nelson, Manager, Assay Development R&D at Molecular Diagnostics at Abbott. And our second speaker, Franca Azzato, Bacterial Section Head, Victorian Infectious Disease Reference Laboratory, Doherty Institute at Melbourne, Australia. Welcome. You may now begin your presentations.
Today, I will present on the design and performance of the Abbott Alinity M-STI assay, a multiplex assay for the simultaneous detection and differentiation of 4 common curable STIs, Chlamydia trachomatis, Neisseria gonorrhea, Trichomonas vaginalis, and Mycoplasma genitalium. These are the disclosures. The program is supported by Abbott. I am an employee of Abbott, and I'm speaking at their request. And the Alinity M-STI assay is CE marked and is not currently available in the US. For today's talk, I will first provide a brief overview of the STI disease state. I will then discuss the design of the Alinity M-STI assay. And finally, I'll discuss the performance of the assay with oropharyngeal and rectal swab specimens, new claims that have recently been CE marked. Sexually transmitted infections have become a growing global health burden. The World Health Organization estimates there were 357 million new cases of curable STIs in 2012, a number that has not decreased in the years since. That is about 1 million new infections per day. 4 of the most prevalent curable STIs are caused by infection with Chlamydia trachomatis, Neisseria gonorrhea, Trichomonas vaginalis, and Mycoplasma genitalium. The worldwide prevalence of these infections range between 0.8 and 5% in women and 0.6 and 2.7% in men, with a high geographic variance in prevalence rates. Chlamydia trachomatis, or CT, is an obligate intracellular bacteria and the causative agent of chlamydia, the most common bacterial STI. It infects the urogenital tract in women and men, as well as non-genital sites such as the eye, throat, and rectum. Neisseria gonorrhea is a bacteria and the causative agent of gonorrhea. It also infects the urogenital tract in men and women, as well as non-genital sites such as the eye, throat, and rectum. Trichomonas vaginalis, or TV, is a protozoan parasite and the causative agent of trichomoniasis. It is the most common non-viral STI in the world and infects the urogenital tract in women and men. And finally, Mycoplasma genitalium, or MG, a bacteria that has emerged as an important causative agent of sexually transmitted infections in both men and women. It is more common than NG, but less so than CT. It colonizes the urogenital tract in men and women as well. I'll go into a bit more detail on each of these organisms. First, CT infects the columnar epithelium of the cervix and urethra, as well as non-genital sites such as the throat, rectum, and eyes. For those, many of these infections are asymptomatic and may not be diagnosed right away, so the patient has the potential to infect others. For those who are symptomatic, women may experience inflammation of the cervix and fallopian tubes, while men experience inflammation of the testes, prostate, and associated structures. Untreated urogenital infections in women can lead to pelvic inflammatory disease, infertility, ectopic pregnancy, and chronic pain. Transmission from mother to child can lead to conjunctivitis, nose and throat infections, and pneumonia. Untreated individuals are also at a greater risk of acquiring or transmitting HIV. Importantly, CT can also infect the rectum and oropharynx, which can serve as reservoirs for future infection for those who engage in oral or rectal sex. Rectal infection can lead to symptomatic proctitis, and pharyngeal infections may cause a sore throat, though it's usually asymptomatic. Diagnosis is critical to ensure appropriate treatment and enhance partner notification. Neisseria gonorrhea is a gram-negative diplococcus and can infect the genitals, rectum, throat, and eye. Neisseria gonorrhea can cause acute inflammation of the cervix and urethra, as well as genital ulceration. Untreated infections can also lead to pelvic inflammatory disease, ectopic pregnancy, infertility, and long-term pelvic or abdominal pain. Untreated individuals are also at a greater risk of acquiring or transmitting HIV. Like CT, NG can infect the rectum and oropharynx and may be symptomatic or asymptomatic. These infections are most prevalent in men who have sex with men who engage in risky sexual behavior. For this reason, the CDC recommends routine CT and NG screening of these extragenital sites for this population. Trichomonas vaginalis is caused by a protozoan parasite. It's the most prevalent non-viral sexually transmitted infection worldwide, and 70 to 85% of patients are asymptomatic. In women, the infection can cause vaginitis, urethritis, and cervicitis, tubal infertility, preterm delivery, and low birth weight. Infected women are at a higher risk of acquiring and transmitting HIV. In men, the infection can cause non-gonococcal urethritis, epididymitis, or prostatitis. And lastly, Mycoplasma genitalium is a bacteria that colonizes the urogenital tract of both men and women. Like the other STIs, most cases are asymptomatic. In women, MG is detected in 10 to 30% of cervicitis cases and may be associated with pelvic inflammatory disease, preterm childbirth, and infertility. In men, MG is responsible for 15 to 20% of non-gonococcal urethritis and 20 to 25% of non-chlamydial non-gonococcal urethritis. Importantly, NG has a high rate of antimicrobial resistance, making treatment of this infection with the current STI therapies less effective. These pathogens have a major impact on specific populations, including those with existing STIs, individuals with multiple sex partners, MSM populations, and transgendered people. Of note, many of these groups overlap with populations most impacted by HIV. The vulnerable populations to these STIs include young people, women, mobile populations, homeless people, prisoners, drug users, and people affected by conflict and civil unrest. Importantly, drug resistance of bacterial pathogens may contribute to the spread of infection to others. The current practice for dealing with these infections is to treat mostly based on symptoms. However, some treatment regimes recommended for a specific pathogen may cause drug resistance to another. As an example, a single dose of azithromycin is more likely to cause macrolide resistance in MG than the extended regimen of azithromycin. So often, treatment for urethritis, pelvic inflammatory disease that is thought to be caused by CT or NG will cause resistance if MG is the actual causative agent. Ideally, before initiating treatment, the clinician would know the exact pathogen causing the infection, so the treatment is appropriate. This is where the use of a single test capable of detecting and discriminating the etiological agent is beneficial. It allows for appropriate treatment, decreases treatment time and healthcare costs, provides timely partner notification, speeds up Sti testing in HIV-infected individuals, and prevents drug resistance. Importantly, appropriate and timely diagnosis of these organisms may lower the spread of STIs, particularly in high-risk populations. The Abbott Alinity M STI assay is such a test that can detect and differentiate these 4 pathogens in one reaction. I will now discuss the design of the Alinity M STI assay. The Alinity M STI assay is able to detect all 4 organisms, CT, Ng, Tv, and Mg, in one single reaction and report the results in under 115 minutes. The assay has been designed to maximize sensitivity and specificity. The molecular targets of CT, Tv, and Mg is ribosomal RNA, which is present at many copies per microbe, thus increasing the analytical sensitivity of the assay. This is important particularly for CT and Mg, since they may be present at low bacterial loads in certain sample types. The molecular target of Ng is the opacity gene, a multi-copy gene with a sequence that is specific to Ng, ensuring no cross-reactivity with closely related Neisseria commensal species. The assay also includes an internal control and a cellular control. The internal control is an exogenous armored RNA sequence unrelated to the STA targets and is included in the amplification reagents. This control is used to confirm that no PCR inhibitors are present in the sample. The cellular control targets the human beta globin gene and serves as a validity check for sample collection, sample adequacy, sample extraction, and amplification efficiency. The Alinity M STI assay also includes a positive and negative control, which are run at a defined frequency. The Alinity M STI assay has been validated for use with endocervical swab specimens, clinician-collected vaginal swab specimens, self-collected vaginal swab specimens in a clinical setting, female urine and male urine for the detection of CT, Ng, Tv, and Mg. The assay has also been validated for use with gynecological specimens in preserve site for the detection of CT, Ng, and Tv. Recently, the assay was validated with additional claims for use with extragenital specimen types, oropharyngeal and rectal swab specimens for the detection of CT and Ng, which I will discuss later in the presentation. All urine and swab specimen types, including the extragenital specimen types, are collected with a single collection kit, the Alinity M Multi-Collect Specimen Collection Kit. The kit is a universal kit that includes a transfer pipette for adding urine, an individually packaged sterile swab for swab collection, and a transport tube with stabilizing buffer and a pierceable cap. The pierceable cap eliminates the need to decap specimens prior to running on the system. The Alinity M STI assay is designed for the Alinity M system, a fully automated molecular analyzer that allows for random and continuous access for up to 20 onboard assays. The system can process 300 samples in about 8 hours with a turnaround time of under 115 minutes. The Alinity STI assay data reduction occurs automatically on the Alinity M system. The PCR signal that is detected for the target analytes are processed through a comprehensive data reduction that involves signal processing, evaluation of PCR reactivity, and determination of sample validity. This process ensures reliable result reporting. Underpinning the data reduction is max ratio, an algorithm that transforms PCR curves into curves with a well-defined ratio peak. This peak reflects the efficiency of the individual PCR reaction and helps determine the validity of the PCR curve. Again, this ensures a reliable result. After data processing, the Alinity M system provides simple result reporting for each of the Alinity M STI targets. Each target in the assay is individually reported as positive or negative. If a sample is negative and fails the internal control or the cellular control, no result is reported and the sample is sent to exception. If a sample is positive but has failed the internal control or cellular control, the result is still reported but gives a flag informing that the control failed. Thus, if a sample has a high enough titer to overcome low sample input or potential inhibitors, the result can still be reported. This strategy minimizes the number of required retests. With a multiplex assay, it may not always be desired or allowed to report all pathogens, so the Alinity M software allows for flexible reporting. The system features result locking, which allows customers to lock out any analyte or combination of analytes from being ordered or unmasked. For example, if only CT and NG are validated at a lab, they may not want to make TV and Mg available. In this case, the lab can lock the assay to only provide the results for CT and Ng. In the future, if the lab validates TV and or Mg, these results can be unlocked and will become available for order. The Alinity M STI assay also features unmasking, which is the ability to instantly report out new combinations of STI organisms to adjust to the growing needs of the clinicians and patients. Results are reported based on the order received for the specimen. Any organism not requested at the time of ordering can be requested at a later time to be unmasked within 14 days of the original order. Thus, if a lab obtains a request for an add-on test, they no longer need to find the sample in order to run it again. They can be made available by the unmasking feature. This slide shows some examples of locking and unmasking. The top scenario shows what will happen if CT and Ng are unlocked and TV and Mg are locked. Only CT and Ng are orderable, and only CT and Ng can be unmasked. The bottom scenario shows what will happen if all 4 analytes are unlocked. All analytes are orderable and can be unmasked within 14 days of the original test. This feature enhances flexibility for reporting and streamlines workflow, saving time and cost to the labs. For the last part of my presentation, I will discuss the key performance attributes of the Alinity M STI assay with oropharyngeal and rectal swab specimen types for the detection of CT and Ng. The limit of detection for extragenital specimens was determined by testing dilutions of cultured CT and Ng organisms in pooled negative oropharyngeal swab matrix and pooled negative rectal swab matrix. 2 different strains were evaluated for each organism in each matrix. For each strain in matrix, a minimum of 3 target levels were evaluated with 20 replicates each. The LOD was determined to be the concentration with a detection rate of 95% or greater. And as you can see, for CT, the LOD claim is 0.5 IFU per assay, and for Ng is 1.5 CFU per assay. Inclusivity of the Alinity M STI assay was confirmed by testing 24 replicates of the following strains in swab matrix over multiple days at the claimed LOD. 16 CT serovars were evaluated, and all were detected at 100%. In addition, 30 different isolates were evaluated at 1.5 CFU per assay, and again, all strains were detected at 95% or greater. Reproducibility of the assay was evaluated for CT and Ng in swab matrix by testing a 5-member panel that included a high positive, a 3x claimed LOD, 1x LOD, and sub-LOD and negative panel. As you can see, reproducibility was excellent with 100% for panels at 1x claimed LOD and higher. In addition, the total SD was small. The assay was evaluated for potential cross-reactants. A total of 32 potential cross-reacting microorganisms that may be found in the throat or rectum were evaluated with the Alinity M STI assay. No cross-reactivity was observed with bacteria, viruses, or parasites that were tested. The potential for interference in the Alinity M STI assay was assessed with 18 substances that may be found in oropharyngeal or rectal specimen types. Again, no interference was observed for any of these substances. To assess the clinical performance of extragenital specimens, a multi-center clinical study was conducted in the United States. A total of 2,390 symptomatic and asymptomatic subjects were enrolled, which included 1,256 males, 1,108 females, and 26 transgender subjects. 3 oropharyngeal and 3 rectal swab specimens were collected from each subject using a common collection device. Specimen testing methods included the Alinity M STI assay and 3 commercially available CT/NG nucleic acid test reference assays for each oropharyngeal and rectal specimen. Specimens were tested by the Alinity M STI assay at 2 external clinical testing sites. The reference results were used to establish an anatomic site-specific composite reference standard, or CRS, using a 2 of 3 rule. That is, if 2 comparators were positive, the subject was considered positive for that anatomic site, and if 2 comparators were negative, that subject was considered negative for that anatomic site. The Alinity M STI assay was compared to the CRS for calculation of sensitivity and specificity. This slide demonstrates the clinical performance of CT and NG by sample type. As you can see, clinical sensitivity was excellent for both targets in both oropharyngeal and rectal, with sensitivity ranging from 93.3% to 97.2% and specificity greater than 99.3% across all sample types. The overall sensitivity and specificity for each analyte across all sample types was 94.3% for CT and 96.2% for NG. And the overall specificity was 99.8% for CT and 99.4% for NG. So in conclusion, I presented on the Alinity M STI assay, a multiplex assay that can detect and differentiate 4 organisms, CT, NG, TV, and Mg, in one reaction from multiple sample types, including the most recently added extragenital samples. We demonstrated excellent CT and NG clinical sensitivity and specificity with the extragenital sample types. The assay includes an internal and cellular control for process and sample check for confidence in negative results. The assay also includes a universal multi-collect specimen collection kit for all sample types, which enables easy standardization across all collection sites. The Alinity M STI assay is an additional tool that can be used in clinical management and public health efforts. And thank you for your time.
Firstly, I would like to thank Abbott for asking me to present on a topic that I feel very passionately about, and that is STI molecular testing. The title of my presentation is Alinity M System, the Future of STI Molecular Testing. Before I begin, I would like to make the following disclosures. Support for the program is provided by Abbott, and I am presenting at the request of Abbott. A quick outline of the points that I will be presenting today. Firstly, I will give a quick overview of STIs, looking at prevalence and current trends, as well as a brief overview of the following organisms: Chlamydia, Neisseria, Gonorrhea, Mycoplasma genitalium, and Trichomonas Vaginalis. Following on from this, I will be presenting data on VIDRL's assessment of the Alinity M, taking a look at operation workflow assessment and a comparison of the assay performance to our test of record. I'll finish with some concluding remarks. STI prevalence and current trends. So there are greater than 30 different bacteria, viruses, and parasites that are known to be transmitted through sexual contact. 8 of these pathogens are linked to the greatest incidence of STI infections worldwide. From the bacterial group, there is Chlamydia trachomatis, Neisseria gonorrhea, Treponema pallidum. From the parasitic group, Trichomonas vaginalis, and from the viral group, herpes simplex virus, human papillomavirus, HIV, and hepatitis B. WHO estimates that greater than 1 million STIs are acquired every day. In 2016, WHO estimated that 376 million new infections caused by one of the following STIs: chlamydia, gonorrhea, syphilis, and trichominosis. Mycoplasma genitalium is emerging as a cause of persistent non-gonococcal and non-chlamydia urethritis in men and may be associated with cervicitis, urethritis, pelvic inflammatory disease, and infertility in women. So this graph shows the increase in chlamydia and gonorrhea rates across Europe, the US, and Australia over a 20-year period. As you can see, there's been an increase in the number of chlamydia cases over the last 20 years, with a spike seen over the last 10-year period. And with gonorrhea rates, there's have been steady between 96 and 2012, but there's been an increase in rates in Australia and the US between 2012 and 2016. So as an introduction to the 4 pathogens that make up the STI panels, let's take a look at the disease state of each organism. So with chlamydia, the causative pathogen is Chlamydia trichomonas, and it's a gram-negative bacteria. It's the most common bacterial STI. Gonorrhea is the second most common bacterial STI. The causative agent is Neisseria gonorrhea, and it is also a gram-negative bacteria. Trichominosis is the most common non-viral STI. It is caused by the parasite Trichomonas vaginalis. And Mycoplasma genitalium is also a gram-negative bacterium, and it has been accepted as an STI since the early 2000s. Site of infection is mostly similar across infections. All 4 organisms infect the urogenital tract of both women and men, with CT/NG also infecting non-genital sites such as the eye, mouth, and rectum. Symptoms are relatively similar across all 4 infections. Symptoms in women include acute inflammation of the cervix, vaginal discharge and dysuria, and in men, inflammation of the urethra and rectum, urethral discharge, dysuria, urethritis, and in some instances, proctitis. If these infections are left untreated, consequences include pelvic inflammatory disease, infertility, and preterm birth. There is also evidence of increased risk of acquiring or transmitting HIV when infected with these STIs. All 4 STIs have similar presentations. Treatment is often syndromic, leading to overuse of antibiotics and the development of antibiotic resistance. Antibiotic resistance is increasing worldwide, in particular for Mycoplasma genitalium and Neisseria gonorrhea, making it very difficult to treat and control transmission. So with the increasing rates of all 4 of these STIs, both globally and at a more local level, and with the increasing rates of antibiotic resistance among Neisseria gonorrhea and Mycoplasma genitalium, there has become more emphasis on the implementation of improved laboratory testing for these targets. In addition, the increase in prevalence has also increased the number of test requests that are being received by laboratories. Therefore, new molecular-based assays that are designed for high throughput work is appealing to many laboratories. As a result, VIDRL was the first laboratory in Asia Pacific to receive the Alinity M system for evaluation. The bacteriology department at VIDRL assessed the technical performance of the Alinity M STI assay against the Abbott M2000, which was used routinely to screen for chlamydia and gonorrhea, and the Aniplex STI7 assay, manufactured by Seegene, which was used routinely to screen for Mg and Trichominosis. We also assessed the advantages of the Alinity M on laboratory workflow and operations. So the Bacteriology Department, VIDRL, services 3 major STI clinics in Melbourne, and we predominantly receive samples from men who have sex with men. We also receive samples from a women's reproductive and sexual health clinic, as well as referrals from external laboratories for confirmation. The majority of samples received are usually sent for STI screening. As mentioned before, many laboratories have seen a correlation between increased rates of notification of STIs and an increase in the number of samples sent for routine screening for STIs. In our laboratory, we have also experienced this trend. Data from the Department of Health and Human Services shows the following, that in a 5-year period to the evaluation of the Alinity M, the number of infections recorded for Chlamydia and Gonorrhea have increased steadily, with a 10% overall increase for Chlamydia and a 15% overall increase for Neisseria gonorrhea. A review of the laboratory data shows that VIDRL CT and G requests have also steadily increased over the past 5 years by an average of 20% yearly. So that's shown in this table here. And this can be attributed to the introduction of PrEP, promotion of PrEP awareness and STI testing, and increase in the MSM population. The table below shows that positive results of CT and G account for up to 5% of the CT and G requests. It seems that there was a slight spike in 2017, which could be attributed to the introduction of PrEP at one of our clinics. So, looking at the Mg PCR and Trichominosis PCR requests received at VIDRL over a 5-year period, there has been a steady increase in Mg requests, on average a 10% increase over the 5 years, and for TV requests, they have remained consistent over the 5-year period. That's shown in the orange here. Laboratory data also shows that Mg positives account for 8% of the Mg requests, shown in this table here, whereas TV positives account for up to 10% of the TV PCR requests. So the laboratory also often receives CT&G and Mg co-requested on the same sample. Prior to the introduction of the Alinity M, these samples underwent multiple extractions and were processed on 2 separate platforms. Chlamydia and Gonorrhea Pcr has routinely been performed on the Abbott M2000 platform, whereas Mycoplasma and Trichomonas PCR specimens were extracted on the TCAN automated platform using a Zymo extraction kit and run on the CSX96 touch system using the Aniplex 2 STI7 assay manufactured by Seegene. Data from the 5 years prior to the Alinity M evaluation was reviewed, and the data showed an increase in the total number of CT and Mg co-requests. 75% of Mg requests were co-requested with CT&G, as you can see by this graph. And over the course of the 5 years, 2014 to 2018, the increase in demand for STI testing impacted our laboratory workflow. So the Chlamydia gonorrhea run increased from 1 to 2 runs per day. The STI7 assay was increased from 1 run per week to 2 runs per week. And daily DNA extractions on the TCAN were below 40 samples prior to 2016, and increased to more than 50 per day. Due to the surge in the number of requests, both staff workload and turnaround time have also increased. So So the workflow for chlamydia and gonorrhea prior to the Alinity M evaluation was as follows. Specimens arrived in the laboratory and they were processed and sorted according to a worksheet. Samples were batched before testing, and this was limited to 96 samples per run. Specimen sorting and batching is tedious with unnecessary hands-on time. So DNA extraction and master mix addition was performed on the M2000 SP, and this usually takes approximately 4 hours. And then amplification and detection was done on the Abbott M2000 RT, and that takes a further 2.5 hours. Data was manually reviewed, and this is an inefficient use of labour as well as causing possible transcription errors. And in all, the turnaround time for 96 samples was 7 to 8 hours. The workflow for Mg and Tv Pcr prior to the evaluation of the Alinity M was as follows. Samples for Mycoplasma and Trichomonas Pcr are received by the laboratory and are processed and added to a worksheet. DNA extraction is performed on the TCAN using a Zymo extraction kit, and this usually takes approximately 3 hours. This is a daily process, and samples are stored at -20 until testing is done. The Aniplex STI7 assay is performed twice a week, and PCR setup usually takes about 50 minutes. Amplification and detection is performed on the CFX, and that often takes about 3.5 hours. And then also data analysis is also manually reviewed. And the turnaround time for Mycoplasma and Trichomonas PCR request was up to 4 days. So demand for molecular testing is expanding rapidly, with molecular assays increasingly being relied upon for diagnosis, treatment, and disease state monitoring of an array of different diseases. With this growth also comes an increasing expectation for accuracy and rapid turnaround times. Laboratories are also constantly under pressure to consolidate workflow and to reduce cost and labour. The hands-on time and manual laboratory processes, including manual testing procedures, molecular training, and batch requirements, often create major staffing difficulties. And this does not just apply to laboratories in Australia, but a global challenge affecting laboratories worldwide. So the Alinity M was introduced in our laboratory to address these challenges. The workflow used during our evaluation was as follows. The sample arrives to the laboratory and it is processed in an Alinity M multi-collect tube. Reagents, consumables and waste were checked on the instrument. Instead of sorting and batching samples like we did with the previous testing methods, samples were directly loaded onto the instrument. The Alinity M reads the specimen barcodes and downloads test requests directly from the LIS. DNA extraction, amplification and detection is all performed on the one platform, and it takes approximately 2 hours. And then data analysis is directly imported back into our LIS. Negative results are auto-validated, and positive and errors are flagged and reviewed by the scientist. So the total turnaround time for 96 samples has been reduced to 3 hours. So the workflow and operational comparison between the Abbott M2000 and the Alinity M showed the following. The turnaround time for first result is about 2.5 hours, about a third of the M2000. Hands-on time per 96 samples was reduced to 20 minutes, freeing up staff to focus on more value-added roles, research projects and professional development. Random access means testing can be performed at any time rather than scheduling tests based on batch sizes, provides flexibility in the event of an urgent sample, unexpected staff shortage, or a sudden change in testing volume. And reagents have a longer onboard stability, and the onboard inventory management will help minimize waste. Workflow and operational comparison for Mg and Tv testing gave similar results to the Chlamydia Gonorrhea workflow comparison. It improved turnaround time, 4 days versus 2.5 hours on the Alinity M. Random access capabilities on the Alinity removes batching requirements for Mycoplasma and Trichomonas, and therefore they can be performed daily instead of twice weekly. Alinity M has eliminated the need for double handling of specimens, in particular for Mycoplasma genitalium requests that are co-requests of Chlamydia and Gonorrhea. This will also reduce cost and staff workload, as we no longer need to manually batch and set up PCR plates. So the data shown here from our evaluation shows that the Alinity M has improved our workflow and laboratory operations. So the Alinity M STI assay evaluation performed at VIDRL consisted of 2 separate studies. These included a performance of the Alinity M STI assay on urogenital samples versus the test of record, and performance of the Alinity M STI assay on extragenital sites versus test of record. The first study looked at the performance of the Alinity M on urogenital samples when compared to test of record. A total of 270 samples were tested. These ranged from vaginal, endocervical swabs and urines. And of these, 62 samples were tested for Chlamydia gonorrhea. These consisted of 48 urines, 12 vaginal swabs and 2 cervical swabs. Results were compared to the current test of record assay, which was the Abbott M2000 real-time CT&G assay. And as you can see from this table, we generated the following results. So 25 samples were positive for CT in both assays. 37 samples were negative for CT in both assays. 6 samples were positive for gonorrhea in both assays, and 56 samples were negative for gonorrhea in both assays. So the Alinity M CT and G component shows 100% sensitivity and specificity. "105 specimens were tested for Mycoplasma genitalium, and 103 samples were tested for Trichomonas vaginalis, to evaluate the STI assay performance on these targets. So results obtained showed that 30 samples were positive for Mg in both assays, 73 samples were negative for Mg in both assays, and 2 samples were positive in the Alinity M assay, but were negative in the Aniplex to STI7 assay. Discordant results were tested using the SpeedX Resistance Plus Mg kit, which is used in the laboratory for Mg resistance testing, and both samples tested positive in that particular assay. So different gene targets and PCR technology used to detect Mg in each assay may account for the Alinity M assay having greater sensitivity when compared to the Aniplex to STI7 assay. Taking a look at the Trichomonas data, 26 samples were positive for Trichomonas in both assays, and 77 samples were negative for Trichomonas in both assays. So this study has indicated a sensitivity of 100% for the detection of Mycoplasma and Trichomonas, and the specificity was calculated at 98% for Mg and 100% for Tv detection. STI testing performed by the Bacteriology department are predominantly on samples from the MSM community. The standard STI screening protocols for MSM recommends also testing pharyngeal and rectal sites. Therefore, there was a need for the laboratory to validate more specimen sites for STI testing. A total of 125 extragenital samples were used in this evaluation. Of these, 93 samples were requested for chlamydia gonorrhea testing. Results show that 25 samples were positive for chlamydia in both assays, 67 samples were negative for chlamydia in both assays, 21 samples were positive for gonorrhea in both assays, and 71 samples were negative for gonorrhea in both assays. There was a sample that tested negative for chlamydia in the Alinity M assay, but was positive in the test of record. And there was equally a sample that tested negative for gonorrhea in the Alinity M assay, but was positive in the test of record. So further investigation of both discrepant results indicated that the results obtained from the Abbott CT and G real-time assay were at the limits of detection for the test, and it's likely that the target of interest was diluted out beyond the limit of detection when the sample was subsequently tested on the Alinity M. So on the basis of this validation, we calculated a 98% sensitivity and 100% specificity for the chlamydia gonorrhea assay. Of the 125 samples, 21 samples were evaluated for Mycoplasma genitalium detection, and 11 samples were evaluated for the Trichomonas detection. Evaluation results are presented in the table. There were 9 samples that tested positive for Mycoplasma genitalium in both assays, and there were 10 samples that tested negative for Mycoplasma in both assays. 2 samples were positive on the Alinity M STI assay, but tested negative in the Aniplex 2 STI7 assay. To confirm the Alinity M results, the 2 samples were tested in the SpeedX Resistance Plus Mg assay, which we currently use in the laboratory for Mg resistance testing, and both of these samples tested positive in that particular assay. The discrepancy, as mentioned before, could be due to the different gene targets, PCR technology used to detect Mg in each assay, which resulted in the Alinity M assay having a greater sensitivity when compared to the Aniplex 2 STI7 assay. The sensitivity was for Mg was calculated at 100% and specificity was calculated at 83%. If we take a look at the Trichomonas, you can see that 1 sample tested positive for Trichomonas, 10 samples tested negative for Trichomonas in both assays, and the sensitivity was calculated at 100% and the specificity was calculated at 100% also. So in conclusion, the Alinity M STI assay provides better turnaround time results than the previous test of record, thus improving the overall management of STIs. Overall, the Alinity M STI assay demonstrated good concordance with current test of record for the detection of chlamydia, gonorrhea, mycoplasma, and trichomonas across different sample types. Alinity M system is a new and innovative diagnostic platform that will provide laboratories with greater flexibility, improved workflow and turnaround times, and staff will be able to work more efficiently and perform other value-added tasks, including research projects to develop new assays. So in my opinion, the addition of the Alinity M system will greatly benefit laboratories with high throughput. It has certainly made a positive impact on our laboratory workflow. So finally, I would like to thank a few people from Abbott. I'd like to thank Adam Zimbrewski, who at the time was the Abbott Molecular Country Manager. Nam Nguyen, who at the time was the Abbott Molecular Field Service Engineer, Lisel Besser, and then at VIDRL, all the VIDRL bacteriology staff, and in particular Eileen Hort, who was the main person in the laboratory doing this work. So I'm happy to take any questions if anyone has them.
Thank you again, Kevin and Franca, for your time today and your informative presentations. We would also like to thank LabRoots and our sponsor, Scientific Affairs Molecular Diagnostics at Abbott, for underwriting today's educational webcast. Before we go, I'd like to thank the audience for joining us today and for their interesting questions. All of your questions will be addressed by our speakers via the contact information you provided at the time of registration. This webcast can be viewed on demand. LabRoots will alert you via email when it's available for replay. We encourage you to share that email with your colleagues who may have missed today's event. Until next time, goodbye.